So rational numbers. What are rational numbers? Rational numbers, the set of rational numbers is represented by Q. Okay. The set of rational numbers is represented by Q, where Q represents A over B, where A and B are integers and B is not equals to 0. In other words, rational numbers are numbers that can be written in the form of fractions. Okay, so if there's any number, if you can write it in the form of a fraction, then it is a rational number. For example, 5. 5 can be written as 5 over 1. So 5 is a rational number. 1.75, can we write this as a fraction? How do we write this as a fractional number?
Seven over four.
How much? No, you look at it directly, how will you write it? If you don't simplify it or anything. It's 170, it's either 175 over 100 or 175 over 100, correct? So we have written this as a fraction. So 0.001 is 1, 2, 3. Okay, so this is 1 over 1000. Okay, 1 over 1000. Negative 0.1 is negative 1 over 10. So all these are fractional numbers. It doesn't matter if it is negative or positive. Okay, rational numbers can be both positive and negative. Okay, so square root 2, can we write this as a rational number? Cannot, we can't write this as a rational number. How about 0.111? 0.111, can we write this as a rational number? Yes, this can be written as an, I'll tell you later why. I think you also know already why, okay? So 0.3333 also can be written as a rational number, okay? 0.345345 also can be written as a decimal number. If you look at all, can be written as a fraction, okay? So all these numbers, except for this number here, all these can be written as fractions. So any number that can be written as a fraction is known as a rational number, okay? Okay, so let's look at what are terminating decimals very quickly, because you've already done this. I gave you terminating fractions. Actually, I meant terminating decimals. Terminating decimals are decimals that don't go on forever. Example, half is 0.5, okay? 3 over 4 is 0.75. These decimals stop here, okay? They divide perfectly and they stop, no more remainders. So they stop here, that means they terminate. These are known as terminating decimals, okay? All terminating decimals can be represented as P over Q, okay? All terminating decimals can be represented as a fraction P over Q, where Q is not equals to 0. Okay, so all terminating decimals are rational numbers. Okay, so if you have a number like this, 0.11111 and continue, this is a non-terminating decimal. Okay, but it is a recurring decimal because the decimal number repeats, it keeps on repeating. Okay, so this is a non-terminating decimal but recurring decimal. This is also a rational number. Non-terminating decimals but recurring decimals can also be written in the form of P over Q. How do we change this into a fraction? We will see later, okay? But these are rational numbers, okay? So when you have a number like this, 0.1111 and so on, the number that is recurring is 1, okay? If 1 is recurring, then you can also write this number as 0.1 with a dash on top. Okay, this means that the 1 is recurring. For the second number here, 0.3333 can also be written as 0.3 with a dash on top. That means we know that this is a recurring decimal and the number 3 repeats. For the next number here, 0.345345. So we know that these 3 digits here repeat, okay? So we can write this as 0.345 with a dash over all 3 digits, which means that these 3 digits will keep on repeating, okay? Sometimes we have a number like this, 0.1723 So what is repeating here is 723 is repeating. So we can write this as 0.1723 and the dash is above the 723. Okay, to show that the 1 doesn't repeat but 723 repeats. Okay, so all terminating decimals and all non-terminating decimals but recurring decimals are all rational numbers. And then we have non-terminating and non-recurring decimals like root 2. Okay, root 2 is actually 1.41421356 and so on. It continues. Okay, it is non-terminating, but it also doesn't repeat. The numbers doesn't repeat. And the other number is E. Okay, this is 2.718281828 and so on. It doesn't repeat. Also with same characteristic for pi. Okay, these are all classic non-terminating and non-recurring decimals. Okay, so these decimals are not rational numbers. They cannot be written in the form of P over Q. They are not rational numbers. If they are not rational numbers, then they are irrational numbers, which we will learn later in the next topic. Okay, so these numbers are all irrational numbers. Okay, so any number that can be written in the form of P over Q in the form of a fraction is a rational number. Okay, so we know that. Okay, normally we use the alphabet Q to represent rational numbers. Okay, what does R represent? When you have a set and we write R there, what does the R represent? Anyone? Real numbers. You already studied this in your MTZ 1024. Okay, real numbers. And then we have integers. Anyone can tell me what alphabet do we use to represent integers?
X.
Z. Okay, Z. How about whole numbers? W.
W.
Natural numbers?
N.
Yes, good. What are natural numbers? We start with what?
1.
Whole numbers?
Start with 0.
Yes, 0, 1, 2, 3, 4, and so on. Integers? Negative and positive numbers. These are integers, okay? Rational numbers or any numbers in the form of P or Q. So all these numbers, you've already seen the whole numbers can be written as a rational number. Natural numbers can be written as a rational number. Like 3 can be written as 3 over 1. It's a rational number. Whole numbers are the same thing. Integers, -2 can be written as -2 over 1. Okay, it is still a rational number. 4 is 4 over 1. Also can be considered as rational numbers. Okay, so if we drew a set diagram, okay, outside here will be our real numbers. Okay, and supposing we had like this, what is the innermost circle? It's supposed to be inside the square. Huh? What's our innermost circle? What does it represent?
Natural number.
Yes, this is natural numbers, and then after that is
Whole number.
whole numbers, and then
Integers
integers
and
and
rational.
rational numbers. Okay, so from here we know that natural numbers is a subset of whole numbers. Whole numbers is a subset of integers. Integers is a subset of rational numbers. So where will our irrational numbers be? Is it part of the circle, somewhere inside, somewhere outside? It is a circle by itself here. Irrational numbers are represented by P, irrational numbers. So irrational numbers and rational numbers, they make up all the real numbers. Okay, so all the real numbers consist of rational numbers and irrational numbers. Okay, so you must remember this relationship. Okay, natural number is a subset of whole numbers. Whole numbers is a subset of integers. Integers is a subset of rational numbers. Okay, so rational numbers can be both positive and negative. Okay, all integers are rational numbers. All whole numbers are rational numbers. All natural numbers are rational numbers. Okay, remember this. Huh? Okay. So we have looked at the definition of rational numbers. Okay. So next we are going to look at using HCF to find fractions in the simplest form. Fractions are rational numbers. That is why we are looking at this here. Okay. If we say that a fraction is in standard form, okay, many of you gave the answers that both the numbers, both A and B are co-primes, which is correct. So A over B is in standard form. If they are both co-primes, that means the highest prime that they can be divided with is 1. Okay, or we can say they are in the standard form if the HCF of A and B is 1. That means the highest common factor is 1. In other words, A and B is in the simplified form. Okay, if A and B is in simplified form, then it is already in standard form. Okay, how do we write a fraction in standard form? We use HCF to reduce the fractions to standard form. Okay, this is revision for you, so I'm going to do this very fast. Okay, so reduce 24 over 30. Reduce this to the simplest form. So first thing to do is to find HCF. Okay, find HCF for 24 and 30. So break down into the prime factors. Find this very easy to do. Okay, it's already 2, so this is 3, 2, 2, 2. Okay, and we have 30 here, which is 6 and 5, already prime factor, 2, 3 and 5. Okay, we know that 24 is 2 times 2 times 2 times 3. 30 is 2 times 3 times 5. So we have same factors here. Okay, therefore HCF of 24 and 30 is equals to 2 times 3 is equals to 6. Okay, So we know that the highest common factor of 24 and 30 is 6. So to reduce this, we just need to divide both numbers by 6. Okay, so 24 divided by 6 is 4 over 5. Okay, so we can use HCF to reduce fraction into its most simplified form, or to write fractions in the standard form. Okay, so I'm not going to do any more examples because we have done this a lot in the last topic, in prime factorization. Okay. Okay, next we're going to look at complex fractions. Okay, what do we mean by complex fractions? A complex fraction is a rational expression that has a fraction in its numerator, in its denominator, or in both. In other words, there is at least one small fraction within the overall fraction. For example, this example here, this is actually x squared minus 9 over x divided by x plus 3 over 5. This is a complex fraction because we have a fraction in the numerator, we have a fraction in the denominator. Okay, so there is a fraction inside a fraction, so it's a complex fraction. And the second example here is 7 plus 1 over y over x minus y. This is also a complex fraction because we have a fraction in the numerator. Either one also is a complex fraction. And if we have another example like this, half divided by 2/3, is this a complex fraction? Anyone?
Yes.
Yes, because it can be written as 1 over 2 over 2 over 3. So there is a fraction in the numerator, there's a fraction in the denominator. So therefore, this is a complex fraction. Okay. Okay, let's just look at one or two examples of arithmetic with complex fractions. Say we have an example like this, 2x cubed over 3y divided by x squared over 6y. We want to simplify this. To simplify this, we have to multiply by the reciprocal. So we change x squared over 6y is 6y over x squared. I'm sure you all know all this very well already. Yeah? So it just a little bit of revision for you. So we have 4x, correct? So we have 4x. So you need to know how to solve complex fractions. Okay, it can be in numbers or it can be in the form of algebra. Okay. Okay, so remember that a complex fraction is a fraction inside another fraction, either in both the numerator and the denominator, or in the numerator alone or in the denominator alone. Okay. Okay, we're going to look at the next concept that we're going to look at is continued fractions. Okay, a continued fraction is an expression obtained through the iterative process of representing a number as the sum of its integer part and the reciprocal of another number. Then writing this number as the sum of its integer part and another reciprocal, and so on. Okay, every rational number can be expressed as a finite, simple, continued fraction. Finite means there's an ending, it stops. Okay, so every rational number, every fraction can be expressed as a simple continued fraction. Okay, so let's see how to write continued fractions. Okay, say we have an example here. I have 137 over 33. Okay, I want to write this as a continued fraction, okay? So before I start, I want to tell you that there are many ways of doing this, okay? So this is the way I like to do it. If you find another way that you think you prefer, you can carry on. Huh? You can use any method that you want, okay? So 137 over 33 actually means how many 33s are there in 137? Normal division, okay? So 137 divided by 33 is 4, right? There are 4 33s inside 137. What's the remainder?
5.
5. So we write the remainder as 5 over 33. Okay. So the next line, I'm going to take the reciprocal of 5 over 33. That means it's 33 over 5. This is for me to do the calculation easily later. Okay. So 33 over 5 is 6 plus a remainder of 3 over 5. The next line, I'm going to take the reciprocal of 3 over 5, which is 5 over 3. 5 divided by 3 is 1 plus 2 over 3. Okay, so reciprocal of 2 over 3 is 3 over 2. 3 divided by 2 is 1 plus 1 over 2. Reciprocal of 1 over 2 is 2 or 2 over 1. And this is equals to 2 plus remainder is 0 over 1, which is 0. Okay, so when you reach 0, we stop. We don't continue anymore. Okay. Okay, so now how do we do the okay? So let's start doing now. Okay, so 137 over 33. We know that this is equals to 4 plus 5 over 33. This is the whole number part and this is the decimal fraction part. Okay, this is the fraction part. Okay, so we know that 5 over 33. This is also equals to 4 plus 1 over 33 over 5. Is this correct?
Yes, madam.
Is correct, right? I can
Yeah.
also write it like this. And I know from what I've done on the left-hand side, I know that 1 over 33 over 5 is 6 plus 3 over 5. So I can write here 6 plus 3 over 5. Correct? You can follow until here?
Yes.
Yes.
So 3 over 5 is also equivalent to is 1 over 6 plus 1 over 5 over 3. Correct? So this is 4 plus 1 over 6 plus 1 over, what is 5 over 3? 1 plus 2 over 3. Correct? I'm getting the answers from the left hand side. Okay. Now 2 over 3, I can write it as this is 1 over 6 plus 1 over 1 plus 1 over 3 over 2. 2 over 3 is 1 over 3 over 2. And I know 3 over 2 is 1 plus half. So this is 1 over 6 plus 1 over 1 plus 1 over 3 over 2 is 1 over 1 plus 1 over 2. Okay. And 1 over 2, 1 over 1 over 2 is 1 over 1 over 2, which is actually later you can miss some steps. Is 1 over 1 plus 1 over 1 plus 1 over 1 over 2 is 2 over 1, right?
Yeah.
It's 2 over 1, okay? So, and we know that 2 over 1 is 2 plus 0, okay? So 2 plus 0, so we don't have to write this already. 2 over 1, we don't have to substitute with 2 plus 0, we can leave it as this, okay? So this is our final answer. So we have written this in continued fractions, or we can also write in a different form. This is the whole number part, okay? So this is our whole number part and this is our fraction part, okay? So we can write this as 137 over 33 is also equivalent to 4 semicolon and then all these numbers here plus the 2. Okay. This one I made a mistake here. Huh? Okay, so this is 1 and we have 6, comma 1, comma 1, comma 2. Okay, so this is our fraction written in continued fraction form. Do you think you can do this?
Yes, madam.
Anybody have a problem? Do you want to see another example?
Yes.
Yes.
Okay, 11 over 7. Okay, 11 over 7. So let's write out the reciprocals first. Okay, so 11 over 7 is actually equals to 1 plus remainder is 4 over 7. So next line, this is the whole number, this is the fraction. We only look at the fraction. No? Next line, we're going to write in reciprocals. So 4 over 7 is also equivalent to 7 over 4. If you don't write this, you want to do straight away also, can, no problem, okay? 7 over 4 is 1 plus remainder is 3 over 4. So here we write 4 over 3 is equals to 1 plus 1 over 3. So 3 over 1 is equals to 3 plus 0 over 1. Once you reach 0, we stop here already, okay? So we're going to use this to continue, okay? So 11 over 7 can be written as 1 plus 4 over 7. This is also the same as writing 1 over 7 over 4, okay? So what is 7 over 4? 7 over 4 is 1 plus 3 over 4. Okay, so if I want, I can erase this here and write it 1 plus 3 over 4, correct? So 1 plus 3 over 4 is actually 1 plus 1 over 1 plus, this is, okay, I show you all steps first. Huh? So 7 over 4 will be 1 plus 3 over 4. So this is also equivalent to 1 over 1 plus 3 over 4 is also equal to 1 over 4 over 3. So this is 1 plus 1 over 1 plus 1 over 4 over 3 is 1 plus 1 over 3 from the left hand side, okay? And here I have 1 plus 1 over 1 plus 1 over 1 over 3 is 1 over 3 over 1. So what is 1 over 3 over 1? Over 1 plus 1 over 3 over 1 is 3 plus 0 or 3. Okay, so once you reach the 0, we can stop. Okay, so this is also equivalent to 1. This is the whole number 1 and we have 1 here, 1 here, 3 here. 1 comma 1 comma 3. Okay, so 11 over 7 is also equal to this. So you can write it in this form or you can leave it in this form. Oh, the best thing is always you finish your continued fraction and then write it in this form. Okay, so supposing you are given the continued fraction like this one here, okay, you're given this continued fraction, say 1 plus 1 over 1 plus 1 over 1 plus 1 over 3. Okay, and they ask you to simplify this. How do you do this? You want to simplify, right? So you must start from the bottom. Okay, so what is 1 plus 1 over 3?
4/3.
Yeah, 4 over 3, right? So this 1 plus 1 over 4 over 3. So what is 1 over 4 over 3? 1 over 4 over 3 is also equals to 3 over 4. Okay, so what is 1 plus 3 over 4? 1 plus 3 over 4 is 4 plus 3, 7 over 4, correct? So 1
Correct, madam.
over 7 over 4. 1 over 7 over 4 is 1 plus 4 over 7. So what is 1 plus 4 over 7? You can do it in two ways, okay? So this is actually 1 4 over 7, which is 11 over 7, or you can write it 1 is 7 over 7, because this is 7, okay? Plus 4 over 7 is 11 over 7, okay? So we got our answer. This is our fraction, okay? That is what this is what we got from our working just now, 11 over 7. When we work the other way around, we simplify it, we get back the answer, okay? Okay, any questions? Can you understand this?
Yes, madam.
Is there anyone who can't understand? This is very important. Now all this will come out in your quiz and maybe in your exam. Is there anyone who can't understand this? Okay, so I assume you can understand. So as I told you just now, you can do any way you like. Okay, you can miss some steps. You can, instead of writing 1 over 7 over 4, you want to write straight away 1 over 1 plus 3 over 4. Also okay. Okay. Okay, so now we have finished with most of the concepts in rational numbers. Okay, we are going to look at problem solving. Okay, first question. Kevin cuts 3/4 of a meter of a wire into smaller pieces. Okay, if each piece of wire is 1/12 of the wire, how many pieces of wire can Kevin cut? Okay, let's draw this out. Okay, Kevin cuts 3/4 meters of a wire into smaller pieces. Say this is 1 meter. Okay, Kevin has 3/4 of a meter. Okay, so this is the piece that Kevin has, and this is 3/4 of a meter, and he cuts this into smaller pieces. Each of this piece is 1/12 of a meter. Okay, each of the piece is 1/12 of his 3/4 piece. Okay, so how many pieces of wire can Kevin cut? So the whole that we have here is 3 over 4. Each small piece is 1/12. So 3 over 4 divided by 1/12 will give us the answer. So this is 3/4 divided by 1/12 is times 12 over 1. This is 9 pieces. Okay, so this, what concept is involved here? Anybody? What concept is involved here that you just learned? What do you call this?
Complex fraction.
Yes, complex fractions. So this problem solving question involves complex fractions. Okay, it's quite a regular routine problem. Okay. Okay, number 2. Okay, let's convert this number to rational numbers. Okay, before we do this, let's do another example. Right? Okay, say we have this number. Okay. Okay, we want to prove that this number is a rational number. So what must we do? What must we show? We have to write this in the form of P over Q. Okay. So what is this number actually? This number is 0.090909 and so on. It's continuing. Okay. So let's say, that x is equals to this number. Okay. So this is our equation 1. Let's say x, this number. Okay. And we know that this number is repeating. Which number is repeating? 0.9. So we want to bring this decimal to the end of the repeating section here. To bring the decimal here, what must we times with?
100.
100, yes. So equation 1 times 100 will give us 100. When you know it, when you times, you must times both sides, right and left. So 100x is equals to, so you times this by 100 will be 9.090909 and so on. Okay, so this is our equation 2. Okay, so now we have two equations. Okay, so now equation 2 minus equation 1, we get 100x minus x is equals to 9.090909 minus 0.090909. So what do we get on our left hand side? 100x minus x will be
99x.
is equals to how
9.
much? On our right is 9, okay, because we have all this cancels off all this, so we have 9 minus 0, so we have 9. Therefore x is 9 over 99, which is equivalent to 1 over 11. So we have proven that 0.090909 is a rational number because we have written it. We have written this number in the form of a rational number. Okay, can understand this? Okay, this way, you do this way if the number, all the number repeats. Okay, 090909, they're all repeating. Okay, but if there is one or two numbers that are not repeating, then you must be careful with what you multiply. Okay, for example, this question. Convert this question to rational fractions. Okay, so let's say that y, you can use any alphabet, y is equals to 0.123323. Which number is repeating here?
2, 3.
2, 3, yes. So say this is our equation 1. 2, 3. So first we need to bring this decimal point to here. Okay? Because when we minus, we are only going to minus those behind the decimal point. So if you don't bring this and you minus straight, you can't minus lah. Okay? So to bring the decimal point here, we need to times by 10. So equation 1 times by 10, you have 10y is equals to 1.232323 and so on. So now you have at the back of the decimal point, you have all the repeating numbers only. Okay? And then equation 1, we want to take it at the back of the repeating numbers. It's 1, 2, 3. The numbers repeating are 2 and 3. So we want the decimal point to come here. So we need to multiply by 1000, correct? So we have 1000. Y is equivalent to 123.23.23. At the back, you can add how many you want, okay? Because they're all repeating. So now we have two fractions here. This is equation 2 and this is equation 3. So equation 3 minus equation 2, you have 1000y minus 10y is equivalent to 123.232323 minus 1.232323. Okay. So 1000y minus 10x will be, 10y will be 990y is equivalent to, how much is this on our right?
1, 2,
2.
122. So what is our y? Therefore, y is equals to 122 over 990. Always simplify the fractions. Huh? So we need to simplify this and we would get 61 over 495. Okay, so we have written the number in the form of a fraction, rational number. Okay, so we have converted the number given to a rational fraction. Okay, so when you are given this kind of questions, first you must identify which numbers are repeating so that you know until where to move your decimal. And then you must also identify whether all the numbers are repeating or not. Okay, if you have a number like this, say if you have a number like this, 0.12454545. First equation is times what? If this is first equation. So first equation we need to times by
100.
times by 100 and you will get what you will get on this side. 100x is equals to 12.454545 and so on. Second equation is equation 1 times by, where do you want to move the decimal? Until 5, right? So you must times by 10,000. Okay, so you will get 10,000x is equals to, so you move this here, this will be 1245.454545. Okay, this is how you must do it. Okay, so you must identify which numbers are repeating. These are the repeating numbers. So first equation, it must come until here. Why you need to do this? So that you can minus these two can minus off and you're only left with the whole numbers. Okay, okay, let's try another problem solving question. A simple question. Maria has 4 loaves of bread which she wants to share between her 8 mates. How much bread does each mate get? So what is your answer? You can see the answer straight away in the question, right? So how much does each mate get? She has 5 loaves. She wants to share between her 8 mates. So how much does each one get? Normally we do what? 5, 8, correct? Each one gets 5, 8, isn't it? But say you have these 5 loaves, okay? So you have 1 loaf of bread, 2 loaf of bread, 3 loaf of bread, 4 loaf of bread, 5 loaf of bread. You want to give 5/8 of a loaf to one person. How do you do that? Practically in real life, okay? So instead of doing it like that, there's another way of doing it practically. The Egyptians like to do this way. They like to, because they develop this kind of division because it's very practical in daily life. Okay, so they have 8 mates. So you divide this into 2, 2, 2, 2. Okay, mate 1, mate 2, mate 3, 4, 5, 6, 7, 8. So how much does each one have right now? Each one have 1 half, correct? They each have a half of a whole. And then you have one more left over. So this one, you're going to divide this into 8. And each person gets 1/8. So each mate gets 1/8. So 5/8 is actually 1/2 plus 1/8. You give them half first and then you give them another 1/8. Okay, so this is practical problem solving with fractions. Okay, instead of telling, okay, each one gets 5/8, it's very hard to visualize and to actually do the actual division. So this is so much easier to do. Okay, this is what we call Egyptian fractions. Okay, this is why Egyptians actually developed these fractions. Okay. Okay, so we're going on to our last topic, which is Egyptian fractions. So I saw that all of you already know what are Egyptian fractions. You've already given the definitions, okay? So Egyptians express fractions as a sum of unit fractions, okay? So let's see how to uh, write Egyptian fractions. So as a sum of unit fractions. Let's look at what this means. Unit fractions are fractions where the numerator is 1. So what is the largest unit fraction?
1/2.
Yes, after less than 1/2 is 1/3, followed by 1/4, 1/5, 1/6, 1/7 until 1/n. So it is getting smaller this way, okay? So it goes as the denominator gets bigger and bigger, larger, it becomes smaller and smaller, okay? So if you had a fraction, say if you had fraction, let's start with 1/2, okay? So 1/2, we can also write it as, because 1/3 is less than 1/2. So we can say that 1/2 is equivalent to 1/3 plus another fraction, correct? Because 1/3 is less than 1/2, okay? So we know that 1/3 plus another fraction will give us 1/2. What is this other fraction? How do we find this? 1/2 minus 1/3. 1/2 minus 1/3, LCM 6, this is 3 minus 2, this is 1/6. That means 1/2 is 1/3 plus 1/6. Okay, what about 1/3? 1/3 is, what is the next fraction that is smaller than 1/3? It is 1/4. So 1/3 is 1/4 plus another fraction. How do we find this fraction? 1/3 minus 1/4. This is 12. This is 1/12. So 1/3 is 1/4 plus 1/12. What about 1/5? 1/5 is the next fraction after 1/5 is 1/6. We always must take the fraction less than the fraction given, okay? So 1/5 is 1/6 plus 1/5 minus 1/6 is 1/30. Okay, 1/30, and so on. Okay, so can you see a pattern here? This is 1/2, this is 1/3, 1/6, 2, 3, 6, 3, 4, 12, 5, 6, 30. Do you see a pattern? So if I have 1/n, so what will this fraction be? 1 over
n plus 1.
Yes, n plus 1 plus 1 over. How do you get 30? 5 times 6. So this will be n times n plus 1. Okay, so we can use this formula to find unit fractions for any unit fraction, but this formula is for unit fractions. So we have developed this formula. So say you want to find Egyptian fractions or break down these fractions into unit fractions. The thing about Egyptian fractions is they write all their fractions in unit fractions and they don't repeat the fraction, okay? So if you want to write 1/12 using this formula, this will be 1 over 12 plus 1 is 13 plus 1 over 12 times 13. What is 12 times 13? 156. Okay. If you had 1/7, it will be 1 over
8.
plus 1 over
1 over
56.
56.
56, correct? If it's, tell me very fast, 1 over 4 is equals to 1 over
5.
5.
plus,
1 over 20.
yes, 1 over 6 is equals to 1 over
7.
plus 1 over
42.
42. Last one, 1 over 8 is equals to 1 over
9.
9.
plus 1 over,
72.
yes. So this is one way of writing Egyptian fractions. These are also known as greedy algorithm for unit fractions, okay? So this is one method of doing it. So just now we did for unit fractions. Supposing you had a fraction like this, okay? Okay, express 4/5 as an Egyptian fraction. So how would you do that? So 4 over 5. You look at this fraction. Is this more than half or less than half?
Less than half.
Yes.
What is half of 5? What is half of 5? 2.5, right? Or 2.5. This is more than 2, and 4 is more than 2.5. Therefore, this fraction is definitely more than half. If it's 4 or 5, half of it is 2.5. Anything more than 2.5 is more than half already. Anything less than 2.5 is less than half. So we know that there is a half inside here. We can take away a half. So minus half. What is 4/5 minus half? Or we can write this as 4/5 is equal to 4 plus what? Okay. So 4/5 minus half is equivalent to 10. 8 minus 5 is equals to 3 over 10. Always check whether you can simplify first or not. Okay, so this is 3 over 10. So 3 over 10, what fraction can we minus this? We know this is less than half already. So we want to check, is this 1/4? Can we use 1/4? 1/4 plus what? Okay, so 3 over 8 minus 1/4. If you cross multiply these two, it must be more than 8. Okay, if it's less than 8, then you can use that lah. Okay. Okay, so 3 over 8 minus 1, 3, oh, sorry, yeah. Made a mistake, yeah. 3 over 10, 1/4. So this is 3 over 10 minus 1/4. So when you cross multiply here, it must be more. If I put 3 here, if I use 1/3, 3 times 3 is 9. 9 is less than 10. So I can't use 1/3. That's why I must use 1/4. Okay. So this will be 40. 40 divided by 10 is 4. 4 times 3 is 12 minus 40 divided by 4 is 10. 10 times 1 is 10. This is 2 over 40. So you see 2 over 40, we can simplify this. So it becomes 1 over 20. When it becomes a unit fraction here, then we can stop already. So that means from here, we can see that 4 over 5 is 1 over 2 plus 3 over 10 here, or 1 over 4 plus 1 over 20. Therefore, 4 over 5 is equals to 1 over 2 plus 1 over 4 plus 1 over 20. Okay? Can understand?
Okay, madam.
Okay, let's try one more, okay? 7 over 8. You tell me, 7 over 8 is equals to what plus what? Is it more than half?
Yes.
Yes, so this is half plus something here. So how do we find that something there? 7 over 8 minus half. How much is this?
3/8.
3 over 8. Yes, good. You have simplified it. So 3 over 8. So this is 3 over 8. Now 3 over 8 is equals to what? What fraction are we going to use here? We start from the biggest and go. So 1/2 cannot. So 1/3 can? Can. 3 times 3 is 9. 9 is more than 8. So we can use 1/3. Okay. So this is 3 over 8 minus 1/3 is how much is that? Okay,
1/24.
yes, 1 over 24. This is already 1, right? So you stop. So this is 1 over 24. Therefore, 7 over 8 is equals to, so this is our answer. This, and this. So 7 and 8 is 1 over 2 plus 1 over 3 plus 1 over 24. Okay? There are many ways you can do this kind of questions. Okay, there's another method that you can use, which is known as the split method. Okay? Say you have 2 over 7. Okay, with this method, we are going to use that formula just now. 1 over n is equals to 1 over n plus 1 plus 1 over n into n plus 1. This method, this formula that we developed just now, okay? So 2 over 7, I can write this as 1 over 7 plus 1 over 7. But you know that in Egyptian fractions, we cannot repeat the fractions, okay? So I must change one of this. So I retain this one. 1 over 7, I leave this here. Second 1 over 7, I'm going to change it using this formula. So what can I change this into? 1 over 7 is equal to, use the formula above here. 1 over
1/8.
8 plus 1 over
56.
yes, 1 over 8 plus 1 over 56. Now they are all unit fractions and they are all different unit fractions, correct? Can I understand how to do this? Okay, to understand that, you must understand this formula clearly. If this is n, this is n plus 1. It's just one more. And this is, how do you get this? You just multiply these two. So if you have 1 over 11, is 1 over 12 plus 11 times 12. Okay. If you have any number, you can write, okay? If it's 1 over 16, then it's 1 over 17 plus 1 over 16 times 17. That is all, okay? Simple, huh? So if I have another question like this, 3 over 7, I can also write, I can do the other way, minus half and minus 1/3 and do, okay? Or I can do it like this, 1 over 7 plus 1 over 7 plus 1 over 7. This is 3 over 7. But I have 3 same unit fractions. I don't want that. So this one, second 1 over 7, I'm going to change it to 1 over 8 plus 1 over 56. Okay, I change this also to the same one first. Okay. Okay. So I 1 over 8 plus 1 over 56. I can keep this, I can keep this, I can keep this. But these two are the same. So I need to change this. So I want to change the 1 over 8 first. So this is what I want to keep. Okay, this 1 over 8, I want to change, use the formula just now. I want to change to 1 over, what is the next one? 1 over, how do we
9.
change? Yes, 1 over 9 plus 1 over 1 over 8 is 1 over 9 plus 1 over 8 times 9. So this is 1 over 9 plus 1 over 72. So I'm going to write here 1 over 72 plus I have another 1 over 56 which I haven't changed this, and this is the same, so I must change 1. Okay, so 1 over 7 plus 1 over 8 plus 1 over 56 plus 1 over 9 plus 1 over 72. Last one, change 1 over 56 to 1 over, this one is the same as 1 over 57 plus 1 over 56 times 57. What is that? So my final answer will be 1 over 7 plus 1 over 8 plus 1 over 56 plus 1 over 9, 1 over 72, 1 over 57 plus 1 over 3192. This is the Egyptian fractions for 3 over 7. Okay, there are many ways you can write it. You can get a shorter answer if you use the other method.